So we started on day one of our unit circle adventure taking a look at a 360-degree circle in degrees and then looking at it in its radian form over to the right. I'll warn you in advance. I want this to be out of your brain. The degrees are going to basically, for the most part, for the rest of this unit, be close to worthless to you. Everything we speak of is going to be, as we keep saying in our Trig language of love, radians. So, I'm not only going to need to know those degree measures in radian, as we're looking at here. We started to talk about yesterday, even though it was very brief, on where these values are also going to come from that go with those. And that in each quadrant of the circle, that I'm going to have these 30, 60, 90, and these 45, 45, 90 triangles. So it's going to be the same values working around the circle that you have up to your right, where we did the radian circle. But you're also going to start noticing, as we do these, you're going to see the same values keep popping up. You keep seeing square root of 3 over 2, 1/2, square root of 2 over 2. And the only thing that's going to change as I move around the circle are the signs on those. So for instance, yesterday, and it looks like I was a bad person and put this in degrees instead of putting them in radians, is when I get to 30 degrees, which is pi over 6. I shouldn't even be doing that. Bad, Harty. I'm going to have a 30, 60, 90 triangle, and we talked about looking at the sides. My coordinates for that are always going to be cosine followed by sine. Luckily, that's how it falls in the alphabet. Unfortunately, some of you may always think sine before cosine because of SOHCAHTOA. And as I move around, pi over 4, not 45 degrees, and pi over 3, or 60 degrees, are going to be the three triangles that I have, and those are going to be the reference points I have with those. And we'll talk about making this simpler in a minute. I've got a quick, easy way that's going to make this circle simple and easy to work with. So as we start moving around it, though, as we get into those last two quadrants, the one thing we made mention of is remembering, and some of you I even heard talking about this, having to do with the quiz yesterday, is remembering where your trig functions are positive. Remembering that in the first quadrant, all of them are. So if you get any degree measures that are between 0 and 90, you're going to have a positive value coming out. And we did with all three of them in this first one. When we move to the second quadrant, though, you'll notice a couple of my coordinates changed in value. You're like, now why did those change? Because in the second quadrant, only sine and its inverse, cosecant, have positive values. So you'll notice every one of my cosine values, which is always the first one, came out negative. All the second ones, my sines, all came out positive, just like they should. So as I keep changing from place to place, so for instance, when I move into this third quadrant, okay, so we had pi here. We don't really mess with it much. We'll talk about it, though. We have 7 pi over 6. And when I get down here, it's going to have the same coordinates that I had here with square root of 3 over 2 and 1/2. But now, in quadrant 3, only tangent and cotangent would be positive, which means both my sine and cosine values take on a negative value now. And as I continue to draw in my other triangles, here I'd have, because we just keep going along here, we got 5 pi over 4. And if you need to reference for now, you can keep peeking up in the right corner there. And you're like, so are these both going to be negative as well? They certainly are. Because in this quadrant, all of our functions will be negative because sine and cosine, again, are always negative in quadrant number 3. And then our last one, our 60-degree reference angle, which is going to be at 4 pi over 3, is also going to have both negative cosine and negative sine values. But again, the numbers inside are never changing. The 30-degree reference always is going to have square root of 3 over 2 and 1/2. The 45-degree reference angle will always have square root of 2 over 2 for both. And the 60-degree is always going to be 1/2, then square root of 3 over 2. They just switch depending on what that reference angle is. So finally, we get to quadrant 4, where cosine and its inverse secant are going to be positive. And if it's not clicking right away, like I said, we're going to talk about some easy ways to do this in a minute to make it a little easier. So here, my cosine will take on a positive value, but my sine won't. And as I finish these up, oops, I didn't put my degree measure on there. Man, I'm just doing all sorts of silly things. Square root of 2 over 2. And again, the sine one will be negative, so that's why the second one keeps being negative in all of these. And we'll get our degree measures on here in a minute. And then we'll talk how it makes this a little bit easier to be able to memorize it. And then again, we'll get our angle measures in. So it's 3 pi over 2, 5 pi over 3, 7 pi over 4, and we'll squeeze in 11 pi over 6 up here. So here's basically how this will work. I'm gonna reference this to you several times in several different ways. I even have a blank one on the back of this sheet that you can use either to practice on. I'll get you another blank one of this in a few days to kind of play with some practice again. But there's one way that you can always, at least for the measures out here, we'll talk about remembering the radian part in a second. But one way to just kind of remember this, the reference angle values are never going to change. So every one of your 30-degree ones that you do that make kind of the smallest little bow tie in here are always going to be a square root of 3 over 2 and 1/2. The only thing you're going to have to remember is which quadrant you're in. Quadrant 1, we're both positive. Quadrant 2, sine's positive, cosine's negative. Quadrant 3, they're both negative. Quadrant 4, just cosine is positive. And you've got to work with that. But these 6 values never change. It's just the signs that go on them. As far as the actual radian values go, when you're just going with 30, 60, and 90, just keep telling yourself, okay, this first one's 30 degrees. It's 180 divided by 6. Oh, okay. 180 divided by what gets me to 30? 6. And you can kind of work your way around that way. And it'll make it go pretty quickly. But it's another one of those things you've got to get used to it and kind of play with it and practice it to make it go a little bit easier on you. But like I said, now do I have mine? Of course I don't have mine with a back on it. There we go. So sometime, and I'll have blanks of this on the website too, if you just get in here, I wouldn't worry as much about the degrees as I would, can I get the radian measures going all the way around for these? And then on top of it, get the values that are going into these slots. Because what I want to talk about here for a second, and I'm going to do this for you on this back one, because I want you to see this where it wasn't in quite of a mess. You'll notice back here, we didn't talk before about what happens when I'm right on one of the axes. And this is kind of one of those strange things. Especially when I got to shrink this down so we can actually fit it. Okay. We've got here what's called a quadrantal angle. And basically what happens is we're going to look at a coordinate point. And we're not going to have an exact value on these. So here's how this is going to work. For instance, when I'm at 0, to find my terminal edge, find my terminal point, I'm going to go out to a value of r, however far that r is. You can almost treat it like a radius, but it's not one. But my y value would be 0 because I'm going up or down, none. So when I do that, and we'll come back here in a second, as I work around these, 90 we know is pi over 2. When I come up here, my y value increases to whatever value I come up here to, but my x value doesn't change. So at 90 degrees, we're at 0 and r would be my coordinate point that I would be at. Because again, I don't have a specific value unless I know where on the y-axis I'm going to be. When I go into 180, I move left on the x-axis. So my value would be negative because we get into the negatives when we move left. And finally, when we move downward on the y-axis, I get a negative r value for my y, and my x is going to stay the same, which is going to mean whenever you're working around on one of these and you're asked to find a value, you're always going to be dealing with the r and the 0. You're always going to get a 0 or a 1 value. We're going to see some of those when we're doing the unit circle notes here in a second. But it's just something I wanted to get on here so when we see it again on the actual unit circle note sheet, it's going to make a little bit more sense, hopefully, when we get there. We'll see. Oh, yes. R is a generic value because it's going to have to do with how large your circle is. So like for instance, if I gave you a value out here, let's say my y value was 3 that I was giving you, but it was on the y-axis. This value would take on that same value, 3. So it's not like the other ones where I can have a definitive like unit triangle like I do with a special. It's more generic. So instead of using x, we use r just because it almost acts as though it's a radius since we're working on a circle. The quadrantals are strange, and we're going to see several of them going through the notes so you can kind of see how the values are going to come out. The calculator even helps a bit too on those. Sure. Okay. Any other general issues so far? Because like I said, we're going to see the unit circle 2 or 3 more times before we see anything quiz-wise with it. Okay. Now we're going to rewind to yesterday for a minute. Some of you are going to have to go digging for a second. Yesterday, the note sheet we never got to, the unit circle. They're like, hang on, we'll go digging. It's here somewhere. A lot of this that we're going to see as we start into the unit circle is going to be stuff that we've seen before. But we're going to try our best to let the actual unit circle help us some. So dig those out. We'll keep getting you some practice with some of these. They're like, it's here somewhere. All right. So here's what we're going to do. When we're looking for a reference angle, this shouldn't be new. Reminder. We're trying to get back to the closest x-axis. Now there's ways with formulas to do this. If you're close to the x-axis on this side, maybe you're going to use 180. If over here, it might be 360. Whew, thank you. So when I'm looking at this, here's what I'm actually doing. I'm asking myself, okay, here's my initial angle, negative 3 pi over 4. My job is to see how far it is to get back to my nearest x-axis, which in this case, since it's going negative, would be negative pi. So how far away is negative 3/4 pi, which is what this is, from negative 1 pi? Negative pi over 4, but here's the one thing. Reference angles are always going to come out positively. So we'll make a couple more little notes here. They're always positive, and they'll always fall somewhere between 0 and 90 degrees. You'll never get a reference angle that's going to be like 150 or something like that. Because if you do, you didn't go to the closest one. And that's where a lot of our reference is going to come from. If it's in degrees, we can allow you to stay in degrees here. And this is the part that gets tricky because people always want to do this. But that's the closest y-axis. That's not what I want. Get me back to x, which in this case, if we're looking at it in degree measure, would be negative 180. So thinking in an absolute value sense, since it's not going to be negative, how far apart are these two? 60. Okay, so my reference angle is going to be 60 degrees. Or in our radian term, pi over 3, because we know pi is going to be equal to 180. So any time with these, closest x-axis, 5/6 pi trying to get to a whole pi. How? Pi over 6. Because you think of it just like a fraction. What's 1 minus 5/6? 1/6. That's what I have left. Now this time we're going all the way around. So my nearest x-axis would get me back to 360. What's my reference angle going to be? 60. Because how far to get back to that nearest axis? Whether it's 360 or 180 or maybe even 0 if it was in the first quadrant, but it'll always be one of those 0, 180, 360 values. So again, that should be a little more type review type things, just to kind of think about it again. Convert degrees into radians and radians into degrees, okay? Degree into radians. Multiply by pi over 180. Radians into degrees. Multiply by 180 over pi. And be cautious. Because some of you, when you're doing it on the quiz, set it up right, but then kind of lost track of where the numerator and denominator are at. If I'm trying to get going here, I always will know I'm doing it right if I can get myself to get rid of the pi's when I'm trying to get into degrees. And some of you start looking at this and you're like, well, wait a minute. If pi really is just 180, can't I just do 180 divided by 3 and not even worry about showing this? That's true. And I would agree. And some of you might just say, so really, what I could do here if I wanted to, if I don't want to try to go strictly into mental math mode on every one of these, you could just take 11 times 180. You could literally use 180 for your pi and divide by 6, and you'll still get to the same angle measure. Very true. And some of you, as you're getting to know your circles pretty well, might get to know that value pretty darn well. Because 11 pi over 6 is our last one on the unit circle. You're like, wait a minute, 330, hey. So this is just a good exercise to get you thinking back about what some of those are going to be. And trust me, as you play with them more, and we're going to do this a lot, it'll be a lot easier to just look at that, and instead of going, well, I need to do pi over 180, Instead, you're just going to be able to look at it and say, oh, that's 3 pi over 2. Or look at 120 and go, well, no, I really don't have to worry much about that being 120. It's just 2 pi over 3. And that's the whole idea of getting to memorize or kind of get to know your unit circle. Because then you see these degree measures, you're automatically going to put them into radians, and you're not even going to have to sit and really think about it that much. But it'll take time. It will, it will, it will. But until then, if you need to, multiply by pi over 180 and then reduce the fraction. That's okay. But we're going to have to get you to a point that just kind of snaps off for you. Find the exact value of each trig function. You're like, okay, so what exactly are you asking of me here? Well, this is negative pi over 3, otherwise known as negative 60 degrees. So what it's asking is, what's going to be the sign at negative 60? Now, you might be looking at your unit circle going, we don't have negatives, though. That's true. So there's two ways I can do this. I can either turn this into a right triangle like we did before, and we'll show you both. I always like to do this. And say, okay, well, if this angle is 60, my reference angle would be 60, because it'd take it to get right back here. So I have a 30, 60, 90 triangle, which I will jumbo here a little bit so some of you can see that a little easier. And then I could just label my sides, my 1, my square root of 3, and my 2, and then find the sign. If this is my reference angle, opposite over hypotenuse, but I'm in quadrant 4. I don't think sine's positive in quadrant 4. Nope, it's cosine. So I'd put a negative in front of it because I know that part. Now what you'll soon find yourself being able to notice is negative 60 would have the same angle measure as a 300 degree angle. So if you look back for a second at your unit circle where the 300 is, I was going to say I just misplaced mine. I'm going to put it on here. There's my 300, my 5 pi over 3. There's my sign, negative square root of 3 over 2. So you'll be able to just look at these and snap them off after a while. It's going to be like you're going, sure, I will. It'll be the same thing as when you're doing your multiplication facts and any other thing you've ever had to memorize. Same idea. Here, negative 135. What's my reference angle going to be? 45 degrees. So if for now I'm still playing the triangle, it'd be 1, 1, square root of 2. Cosine is adjacent over hypotenuse, but I know I can't leave it that way. And then the only other question becomes, is it positive or negative? All students take. Ooh, that's not tangent. What degree measure would it be equal to? 225. What's 225 going to be? Negative square root of 2 over 2. So you start to see the connections with the unit circle and not having to draw a picture every time that you do this. But again, it takes time. I'm not going to say it doesn't. It will, it will. So I want to do a couple here at the top, and then I'm going to do a couple down here without the pictures and kind of get you going with some of these things a little bit. Now, one thing we hadn't discussed on the unit circle. We always did sine and cosine. We never talked about tangent at all. Why is that? Because we use the sine and cosine to get ourselves tangent. When we're doing tangent of theta, we are going to take the sine of theta and divide it by the cosine. So here's how this is going to work. At 330 degrees on my unit circle, so right here, here's my cosine, here's my sine. So I look and I say, okay, so square root of 3 over 2, negative 1/2. So sine is going to be 1/2. I'm going to be dividing by, oops, negative 1/2. Almost messed this up. I'm going to be dividing by cosine. Square root of 3 over 2. And we know what happens whenever you divide by a fraction. You flip it. And here's what you're going to notice. Every time, those are going to wipe out. This is going to become like anything else. Ooh, I got to rationalize this. Yes, I do. If I multiply by the square root of 3 in the numerator and denominator, I get to my solution. But again, instead of drawing the pictures each time, I would start using my unit circle that I've got drawn. And you actually picked up another one today. The sheet 17AB that you picked up on the back's got a unit circle completely done with the triangles and everything. I just wanted us to see where it comes from first. So if you want one that's possibly a little neater to reference, you can. But that'll be true with any of these. Tangent of theta, tangent of pi over 4, 45 degrees. So I'd be like, okay, so I need to do my sine of 45 degrees, which is the square root of 2. And I'm going to divide that by the cosine of 45 degrees. Which is, anybody? They're like the same thing. Okay, so we've got square root of 2 over 2. Divided by square root of 2 over 2. That's interesting. What happens when you divide something by itself? I know what's thinking in somebody's brain if somebody hasn't tried it yet. They're like, hey, if I know that's 45 degrees, couldn't I technically, once I made sure that if I was in degree mode, if I was going to do it in degrees, otherwise I'd have to do it in this, couldn't I technically just do... Yes, but I'll warn you. There's going to be a minimum of 1 quiz before we get to the test, and possibly 2, where calculators aren't going to be allowed. Because that's how much we're really trying to stress understanding your unit circle and how to use it. So this is a nice backup for right now. If you're doing something and you want to double check, you can. But I wouldn't get hooked into this thinking that's the only way I can get the answers to anything. I really want you to try to use the unit circle just so you work with it more and can play with it. We're just going to mess with a few of them down here without pictures and kind of see how this goes. Now let me explain when we get down here. Down here I can do a couple of things. I can either look at them as degrees. Maybe even I want to try to look at these more as radians instead. So like for instance, I might pull out this other unit circle thing that I had and go, okay, it says 300. So here was 300. Okay, my 5 pi over 3. I've got that. And I also see on here that my cosine and sine are right on here. So couldn't I just look at this and say, well, cosine is going to be 1/2, and I'm done? Yes, because I want you to start thinking about this unit circle as far as, oh yeah, 5 times 180 is 900 divided by 3 is 300. Okay, and start associating these with them. At the very least, the other way you could do it, and I've had students do this before, they look at everything with reference angles and then figure out the signs. You're like, what do you mean? If I'm at 300, my reference angle would be 60 degrees. So I'd think, okay, cosine of 60 is 1/2, and is 300, is it positive? That's quadrant 4. All students take calculus. Yeah, it's positive. That's another way you can get the hang of this as you're going. So if the reference angle idea makes more sense to you, sine of 60 degrees is square root of 3/2, okay? But is sine positive when I get to quadrant 4? All students take calculus. No, it's negative. So either you can be pure memorization on that circle, or if you have your basic reference angles ready and you know these 6, you can just play the game in your head of what quadrant you're in to figure out what the sine's going to be. They both work. It's just a dependence on which way would you rather do it. Now tangent gets a little more interesting. Because you're like, negative 240. Oh boy. Reference angle, negative 240. Negative 180. 240 is about here. It's my reference would be 60. Because that'll get me back to this negative 180. So 60 degrees. Tangent, remember, is sine divided by cosine. So sine at 60. They're like, really? You're going to make us talk about this? Yes. Square root of 3/2, but it's not going to be positive here. All students take calculus. My cosine is 1/2. Again, at negative 240, my sine's okay. My cosine would take its negative, and then I just work this out. That flips up, the 2's cancel, end up with the negative square root of 3. And it is. I'm not going to say it's bad if when you're doing this first assignment, oops, get that back in here, if you're literally hanging on to this unit circle and just looking back and forth for dear life. It's going to take some time. But do, again, start getting used to, okay, I'm going to look it up on here. Oh, yeah. And start finding ways that are going to be simpler for you. But I do want to do a couple of them that end up on axes, like sine of 270. Instead of using r necessarily, because I'm noticing this other unit circle is going to be a little more general, which I'm okay with. When I'm doing sine of 270, okay, they've got 0 and they have negative 1. Now let me explain where these come from. If we use our r's from before, like I had here, I'd have to draw a right triangle and my hypotenuse would be r. So it would be negative r divided by r. But this is probably going to be easier to remember than that. So sine of 270, just include it in with your unit circle when you're trying to figure out how to memorize it. I would just start using it with the 0, negative 1, and the other ones on the way on the outside. Like I said, we're going to get some practice. I'm going to get some blanks out. We'll kind of keep playing. But that's how I'd reference that for right now. So here's what we're going to do. We're going to kind of do this like we did yesterday. I keep playing this day behind thing. So for tonight, I would just work on the worksheet that you got with this unit circle stuff from yesterday. Work on playing it. We'll deal with the circular functions notes and that tomorrow. So we'll just kind of bump back one more day, which isn't going to be a big deal. It just bumps us back one more day for the next homework check.